I think every SaaS product book actually put everyone in the wrong direction for deep tech. It doesn't work that way in deep tech. Like, it's not about customer interviews from day one. It's about understanding maybe a problem, understanding that very deeply, but you don't put a product in front of someone until you understand the tech. You may not be able to know what to build until you're in the problem space well. So understanding the problem space is the key, and then actually going and figuring out how to build that with the right team first. There's no customer centricity yet. That happens when you have a product. So when you're in the SaaS world, you're thinking about, that's how I present stuff to a user, is my UI. Yeah, then you got to think about that from the get-go, because most of your innovation is in the UI. When your innovation is in the tech part of it, first you got to innovate there. You got to build the tech. Then you got to figure out how to package it and sell it. So I think getting that over the hump is your initial task in a deep tech company.
Naveen, I'm thrilled to have you here today. I spent a lot of time on Barchives and just in life diving into how companies are harnessing AI and strategically using their internal data. And you've been at the forefront of all of this. And with 2 successful exits under your belt, expertise in hardware and software, now leading generative AI at Databricks, we're going to have a lot to get into, a lot to talk about. Thanks for coming on.
Absolutely.
I'd love to rewind, though, before we talk about the present state of AI, the future state of AI, to the past. Before you sold Mosaic to Databricks and before you sold your previous company, Nervana, to Intel, you were a kid in Kentucky. Your family was all doctors.
Yeah.
I heard from Casey, there's not a lot of Kentucky representation on the team. So I want to hear about Naveen as a kid. What were you like? What were you interested in?
Yeah, I mean, what's interesting is that I would say maybe as like in middle school, that kind of time, like call it 12, 13. I actually was really into AI back then, like the concept of it. What's pretty interesting is that it's kind of where I wanted to be. I'm where I wanted to be in a sense,
That's amazing. I didn't realize I knew you were an early adopter. I didn't realize you were such an early adopter.
Well, it came from reading a lot of sci-fi and stuff like that. I mean, all the early, Isaac Asimov, Arthur C. Clarke, Robert Heinlein, all of these things, they almost all had some kind of AI bend to them, and these are things that were been written over the last 60 years. So I think it's been a topic in science fiction for so long. It was always fascinating to me about, what is different about our brains? What do we do that we couldn't do in a computer yet? And why? Why can't we do that? And I've been an engineer since I can remember. Honestly, I love building stuff. I learned how to program when I was in elementary school. I learned how to start building circuits and things like that when I was in middle school. I built like a buzzer system for our academic team, I did all this. It was fun.
I don't embarrass you. I wasn't sure. Through some Google searching, I did find an old article that you were voted the Whiteburg High School most likely to succeed. So,
okay. What was that, Mountain Eagle? That was the name of the paper?
Yeah, it was, I don't remember the name of the newspaper, but.
Okay, wow.
I'll link it.
Oh man, okay. Yeah, I guess I was always kind of a geek, but I always had I always loved sports. Was kind of always athletic. I did sports all through high school.
Yeah, I know you're very into racing cars, but we can get into that. So, okay, you went on, and from a very young age, you had this interest, and then you went for it. You studied EE and computer science, went off to work as an engineer for nearly a decade, and it's very rare for someone with a decade of work experience and really good jobs to go back and do his PhD.
Yeah.
So I'd love to learn a little bit about why. Was that an easy choice?
Okay, as a choice, it was easy for me. To actually implement, it's difficult, right? There's other people in your life at that point. I had 1.5 kids and, all that kind of stuff. So I think, like I said, I was super interested in this idea of, thinking of the brain as a computer. How can we build better computers? And that was actually when I went to undergrad. Initially, I wanted to do biomedical engineering, which would have been, really along the lines of how do we understand concepts from the brain, and it's almost like bio-inspired computing or something like that. And there really wasn't such a thing at that time. And I went to Duke actually, and partially because they had a very good biomedical engineering program. I tried to do biomedical engineering, and then I also loved electrical engineering and the kind of physics aspect of it, and do computer science. I couldn't do all three. It was just too much time. So I was also pre-med.
Oh, wow. You considered being a doctor and following in the family footsteps?
Oh,
or was
I had
for fun, for extra?
Oh, well, no, it was not for fun. It was because I'm Indian and I had to do it. No, I did all the pre-med classes. Actually, I stayed over the summer and did like organic chemistry. I took the MCATs. I did all that stuff. But when it came down to it, I just didn't want to go that direction. I love building too much. And I got a taste of that when I was an intern at IBM, and after my junior year, I worked on microprocessors, and I just loved it. I just wanted to build stuff. And I think, like I said, I've been an engineer since I can remember. I'm just wired that way, I think. So yeah, anyway, I came out to the Valley, and I'd finished EE and CS, but I actually done computational biology courses as an undergrad. And there's one professor I had who was a CS professor, but he also taught in the med school. Kind of strange, right? His name is Frank Starmer.
Less strange today, but probably pretty strange then.
That's right. He was definitely an outlier then, but I think he's actually the one I learned so many things that I still impact me today. That's where I found out that the brain runs on 20 watts of energy, and your eye does a real-time Laplacian transform just by the way it's structured, and does edge detection. And so there's signal processing happening in our organs that the evolution sort of came up with, and we can characterize those in precise mathematical ways, which just blew my mind at that point. I'm like, wow, this is like an engineered system almost. So I loved it. I did like neuromorphic research as like a kind of a senior project, a senior thesis, and that was following up on Carver Mead's work of building essentially neurons in silico. I didn't actually build them. I did it with simulation, but anyway, I think that was where a lot of that desire was born. But when you come out to Silicon Valley, that was before the dot-com bubble and all that stuff. Like you get pushed into this world, and so I did that, and I learned obviously how tech works, and I built several processors and chips, and learned how the technology works. But that desire to actually go back and understand what the brain was still there.
Okay, Naveen, when you then had the opportunity to go deep and spend your PhD focused on the brain, you did then neuromorphic research at Qualcomm. What surprised you the most? You always had this interest, but now you had the opportunity to really, really focus there.
Yeah, I think one aspect was viewing the brain as an engineer, someone who's designed, computing systems, things like that. Was first you look at it, it looks very messy, and it's just this big blob that looks like lots of arbitrary things. But I feel like the deeper you get, the more you start to appreciate the beauty of the structures that exist. They're not messy. They're not random. It's a very finely tuned system that evolution both made extremely finely tuned, but also very robust. So biology is actually like, I think just brilliant engineering is what it comes down to at the end. And it's literally battle tested, right? So I think understanding and having an appreciation for what biology is built, and then trying to extract some concepts is what I find extremely rewarding. And there's so many things to extract because it is such a highly tuned system. And I think we're still scratching the surface. I mean, maybe we extracted some concepts about learning now and how large distributed systems can learn. When I did my PhD, it was not really common accepted knowledge, at least, that a computing system can be built in this large diffuse way. Now we see that training large neural networks means having lots of interconnected nodes and things like that. We did bake a lot of those things into the Nervana product initially. Like this idea of a distributed computing platform from the get-go was actually what we built in 2014. So some of those concepts came early, for our group.
Yeah, I'd love to talk about Nervana, but you said that going to do the PhD was an easy decision for you. So yeah. I'm curious if it was easy because you were very interested, or if you thought that you then want to start a company and have a foundation. You thought you want to go into academia. You have a very unique route. So was it interest? Was it something else? Was this a tool that you needed to then create Nervana?
No pun intended. It was really based in interest, honestly. It was one of these things, I got to a point where I was like, I could stay in Silicon Valley. I could do, I had a great career. I was a really good engineer and had lots of offers always on the table. So things were going very well, but it, in some ways was like, I felt a bit unfulfilled because I was like, I wanted to be part of the next thing. And really, to me, it felt like I didn't know what the time frame was going to be. Mind you, this was in 2005, 2006 timeframe. We didn't really know if AI was going to be a thing, but I was like, okay, you know what? If I go down this route and it's 50 years from now, at least I'll have been a part of the basis. And that's the way I work.
Yeah, I can be part of the foundation, even if I don't see all the fruit in my lifetime.
Exactly. And I feel like that would have been very rewarding for me. And it wasn't driven by money. In fact, it was a horrible financial decision to go back to grad school at that point. But it was really about interest. And when I went, I actually fell in love with research and actually thought about going down the academic route. It's just academia is very hard when you have a family and all that, just from, you make no money. It's really, really. So unless you came from, very, I guess, rich roots or something like that, it was very hard to make it work. And so I couldn't do it. I needed to get a job.
Well, you've been very effective at building companies that have really, really strong research organizations. So let's talk more about Nervana. Talk a little bit about what Nervana did.
Yeah.
And then I'm curious, looking back, what you think you got right and what you think you got wrong.
Sure. Yeah. I've thought about that a lot. So what we did was we actually proposed the first hardware startup, the first hardware startup that most VCs had seen in at least 10 years. This was 2014 when we started, and most hardware startups kind of went out of fashion in 2005. And really, that was based around networking and video compression, a few things like that. Which, there were some very big winners in that race, but then a lot of it died. And I think a lot of VCs felt they got burnt because they put a lot of money in hardware companies and they died. So when I came by and said, look, I think AI neural networks are a new computing paradigm. They require a rethinking of the architecture of a chip. It wasn't just a CPU that was going to make it work. And even the GPUs at the time weren't quite right. So we said, okay, we can build an architecture that can actually work for this kind of compute. And that pitch was clearly right. That was obviously now a GPU is an AI processor. Like what they've done to it over the last 10 years has made it into an AI processor. It was hard at the beginning because most VCs didn't want to go that direction. You had to have people who were a little bit more forward-looking and maybe understood technology better, like Steve Jurvetson. He was one of the people who really got us off the ground, led our Series A. But beyond the hardware side of it, like you have to understand what to build. And this was something that I don't think everyone understands how hard it was at that time. It wasn't super clear that neural networks were going to be the winner. It wasn't super clear even what flavor of neural networks were going to be the winner. ResNets had not yet come out. And people look back and they're like, oh, you just built hardware. It's like, well, guys, building the hardware and actually speccing it the right way took a lot of understanding of the specific workloads. So we actually had a research team of people who really just came out of academia. Most of the folks we hired were either postdocs or fresh PhDs who understand either statistics, machine learning, and or deep learning. And really, we had to then figure out, okay, what can we get away with in hardware that will actually work and make these neural networks train? What would we have to change? How could we actually make it work at scale? How could we scale it? Like no one had even thought through parallelisms at that point, really. There were simple parallelisms that were in Alex Krzyzewski's paper and Ilya Sutskever's paper just before then, but it was only within a box. So we were thinking much bigger parallelisms. So anyway, I think we need foundational research to make that work. And so we had to build an org that was exploratory enough to go and understand where the world was going and then kind of come up with an opinion of what we should build in hardware.
Yeah. Anyone who says just building hardware, well, there's a lot discounted there, but one of the nuances is that how quickly software moves versus how quickly at the time hardware moves takes a while. Software starts moving in a different direction, you're caught holding the bag.
Exactly. Yeah. And we had, I think one thing we got, I wouldn't say wrong per se, we got right the idea of going to lower and lower precisions. So in 2014, high performance computing was actually defined by 64-bit floating point precision. If you looked at the figure of merit, like flops, of these supercomputers, they're always quoting the 64-bit precision. At that time, 32-bit was okay. We could make it work. And that's why everyone was kind of, yeah, that's fine. We actually suggested to go much lower. I actually wanted to go to 4-bit, 8-bit. It was a little bit early for that. We still had to understand how to make these things work properly, regularize them the right way. There was a lot of things that had to be invented. we defined a new numeric format. I think we even got a patent on it called flex point, which you can call a block floating point format. Basically, you maintain one exponent for a bunch of mantises. Mantis is the main base number. So we built that into the hardware for the first revision. I think it was a bit early to go in these kind of I'll call it exotic numerics. We did it for the reason that we wanted to make something that was lower power and potentially higher density, and we could build this circuit to be lower power, higher density. I think what we probably should have done is just stick with floating point, make it go to FP16, which we had done in the GPU already through software, and then we go to FP8 or something like that early on. So that probably would have been a better choice, but it wasn't wrong. And now there's actually block floating point formats that work, but it takes a lot longer than you think to make these things work.
Was the choice to sell to Intel an easy one? I'd love to hear a little bit about the before and after acquisition.
Yeah, I get asked about this one a lot. And I think in retrospect, I don't know, it wasn't the right decision. We actually had something very special at that point. We were very much ahead of NVIDIA at that point. So, 2020 hindsight, I suppose. But the drivers of selling were a fewfold. One was, this was 2016. We had been on a quote unquote bull run in the markets for about 5 years. 2011 is when the market started to pick up. My past of seeing the .com boom and bust and all of that, I was like, I don't know, something bad is going to happen. So I was fearing that there was going to be hard times ahead in terms of being able to raise money. We needed to raise money for a hardware startup. Also, was it too early? I don't know. You just don't know these things. And then also, I as I said before, going back to grad school was not the best financial decision. I went through a divorce. I had 2 kids. You have to make life work. And, I didn't take a salary for the first 8 or 9 months. And then, all of those things, it wasn't super, super great, and as an individual, I really kind of cut my life back to its bare bones without compromising my kids too much. But at the same time, like, my kids were growing up and they're gonna have to go to college and all of these things, which they're now doing. But this weighed on my mind. And so there's this offer that comes in and you're like, that takes all the pain away,
Yeah. It's there, it's in front of you. These are the practical decisions you have to make.
And you convince yourself. I mean, I was like, okay, if I'm part of a bigger entity, we can invest bigger, stronger, and we can possibly go win. That was really what I told myself. And I think that was true. What I underestimated big time was the politics, the resistance, the friction, the foreign body rejection, all of these things that come with an acquisition.
What do you think that stems from? Is it just large organization, or do you think it looks like something else in predicting where the hardware market is going?
I mean, every large organization is resistant to change, and by design. So it's actually not a bad thing. Large companies are highly optimized machines to deliver the thing they deliver. So Intel was very optimized to build CPUs and process those in the fab and all that kind of stuff. Anything that potentially deviates from that is both a threat and unimportant, right? That's how every large organization works. It's the design of the organization. It's like, no, that is not the right way, because what we built is the right way. It has to be, right? If it's not, then this organization shouldn't exist the way it does. And I think that's the tension that causes these problems. And so when you come in and you're saying, hey, look, you had a great run on CPUs, but I'm telling you, the future of computing is not about the SaaS application. The future of computing is about AI. Everyone's like, you're crazy. You're crazy. It's not true. There's no way that's true.
Well, it's nice to get validation that you're not crazy. I'm always looking for that. So.
I knew I wasn't crazy. I knew it. I said it very confidently because I knew that what was happening.
Yeah.
But it's very hard to convince people.
There's a lot of focus today, obviously, on using GPUs to accelerate transformer models. I'm curious what you think of the current state of hardware. If there are innovations that you're excited about, is there room for new exciting startups today?
Well, I mean, NVIDIA they embraced it very, very strongly, because if you think back to that time, like I want to go back and look at the numbers exactly, but 2012, NVIDIA's market cap was like maybe 5 billion. It was tiny. They were on the brink. Everyone had called discrete graphics, which are graphics cards for gaming, a dead market. And basically they were trying to find relevance in other markets, and they went to high performance computing. And this is where CUDA was born, a few years before then. And, they were looking for that killer app, which high performance computing is a really shitty market. It's all government funded. It's $200 or $300 million total as a market. And, it's not a place where you can really grow. And so NVIDIA was trying to go after that, notch up some supercomputer wins, like biggest computer in the world, those kind of things. That's good for bragging rights, but it's not a big market. And so when AI came on the scene, I actually remember very famously 2014 GTC. That's when right after we started Nervana, they went all in on AI. And the graphics people were pissed because they're like, what the hell? What are you guys talking about this thing? You don't make any money on it. But I think Jensen saw that this is our opportunity. We got to jump on it.
Yeah.
And so they basically went down the route of building a chip that was highly optimized for AI. Now, to your question about are there opportunities? I think the answer is yes and no. I mean, there were lots of opportunities earlier. NVIDIA is a giant now, and now we have AMD in a resurgent way and all the clouds. Like, you're fighting a really, really hard battle, and something that's just an incremental tweak on an architecture ain't going to cut it. I see so many of these pitches, and I'm like, guys, do you really believe that NVIDIA or AMD has not thought about that? There's a reason they didn't do it.
Or maybe they are doing it. Like, maybe they're devoting some area of research to a new architecture so that they're prepared to pounce if they need to.
Absolutely, they are. I know for a fact they are. So these are very smart people, and they're going to pick the low hanging fruit. You got to think bigger and think differently, and I love it in a sense because it forces this creativity. Like, you're not going to win just by some little package thing that you can put in a hardware, and you might have a gain that it will erode in a generation. That's not going to work. You need to be like something truly innovative to win, and that I haven't really seen that yet. I mean, I see Cerebras. They did something actually pretty big with the wafer scale stuff. So I like what they did. Is it going to win or not? I don't know, but there's a lot of reasons we can discuss if you want. But other than that, a lot of companies, a lot of startups are just doing the same kind of thing. They're doing a little more flops, a little more memory bandwidth. But honestly, those aren't going to do it. It's not going to cut it.
Speaking of large innovations, you mentioned that you've been into AI for a long time. Yeah. And you knew that you want to be part of the foundation, but you weren't really sure about the timeline. Maybe with each cycle working in it, you get more, and seeing all the progress that's been made, you get better predictions around timeline. So I want to talk about your second company, Mosaic. Yeah. What gave you the confidence that the world was ready for custom large-scale model training when you launched and founded MosaicML?
Yeah, again, it was kind of obvious to us in a sense that I put together this framework for how I think about timelines, because everyone talks about vision. They're like, oh, that was a great vision for a product, but it was off in time. I actually argue that's a bad vision. Vision and timing are one. You have to time things right because you have to have the economics for a supply chain or the ability to build something that's actually economically feasible. That's vision. So when I look back at that time, I said, well, I knew neural networks were growing in size. They kept doing more. This is right around the time that transformers were being scaled up. We saw these things happening in the field, and it was pretty clear that it was going to add value. I mean, GPT-2 or GPT-1 had already come out, or maybe just before then, right around that time. So we saw these capabilities coming right around that time, and so it was clear that there was something big happening, and it's going to involve scale. Scale was hard. We need to build the software layers to make this easy and repeatable. So that's really kind of where we went with Mosaic. And my framework for thinking about these things is, if something's a really big idea, okay, well, is it going to happen in 50 years? Oh, it's definitely going to be less than that. Okay, so I can say now, is it going to happen in a year? No. So now I have some bounds. It's between 1 and 50. Then I can start to do this kind of thought exercise of, is it 10 years? Is it 5 years? Is it 20 years? Is it 7 years? Like, you can actually, when you start thinking through a problem like this, you can actually say like, well, I think I can come up with a 90% confidence bound that's 7 to 20 years. It sounds like a lot, but it's actually giving you way more information than, oh, I just don't know, right? So I think in that way, I sort of reasoned through these things, and I like to find ideas that are in that 2-year window before anyone really thinks about it, and that's the most investable place to be.
Yeah, well, I'm curious, you put your stake in the ground and you said, I think that in the next 2 years, this is going to happen.
Yeah.
What do early customers then look like who are on the edge with you and have this interest? And I'll explicitly ask pre and post chat GPT, because I saw, very, very different need from customers pre and post as well.
Yeah. I think pre-ChatGPT, or even the very beginning of the company, we were focused on the builders who build this stuff, right? They could be in any customer. They could be in a big tech company, or it could be in a startup, or even a large enterprise potentially. I mean, some of the financial institutions have people who are quite good and quite capable of building stuff. And so we basically probe this through that world. We put our open source software out. If someone wants to use it, we want to understand why they're using it, what do they care about. And so, in this way, we got a sense of like, okay, these are the things that people might want help with. These are problems that we can help solve. And then we actually started thinking about, well, being able to stitch together all of these GPUs in the back end and actually make the whole process super reliable was a path to doing something meaningful, was something that people wanted to pay for. And that actually, we got the early signals from even PhD researchers, like people who are in their PhDs. So after ChatGPT, what's interesting is that we were kind of on that path. We actually went down the transformer path already, large scale stuff. We started publishing things around transformers and costs well before ChatGPT. I think one of our biggest blogs that was referenced heavily was the cost to do GPT-3 being something like $150,000. We published that in October of 22, so about a month before ChatGPT. So we were already down this path and we were getting good traction. But then ChatGPT came, and that's when the enterprise just sort of woke up. And then everyone's like, oh my God, I need this thing. So we were well poised. We had built early versions of the tool already. And so from that point, like through the beginning of 2023, we couldn't stop. We kept selling constantly. We couldn't stop selling. It was like crazy. It was myself and one other salesperson.
Well, I'm curious, given your hardware background, and it sounds like the path on research to incredibly fast scale and demand from customers, how did you think about your hardware? Like, you're no longer building it in-house. I think you used Oracle Cloud. A little bit on that decision.
Yeah, I mean, there's a couple of things here. So we didn't build hardware, but we're very close to it. So I mean, yes, I had a hardware background. I also did a lot of work in algorithms, in software. So really, it comes down to being able to make the physical system do what you want. And that's a combination of low-level software, systems design, and hardware. And so, yeah, while we're using someone else's hardware, we can do things with that hardware that made it more efficient. And that was largely what Mosaic was about. Could we find 3 or 4x efficiencies through clever tricks, algorithms, and software optimization?
How do you find the right people for your team that can do that? Like, how did you recruit? What was your hiring philosophy for Mosaic?
Yeah, I mean, people understood systems. That's really important. So you have to understand the low level stuff. Like, it's interesting because there was this period of time, and it's kind of diminishing a bit now, but there's a period of time where computer scientists just became divorced from the hardware. It was just like they thought in these theoretical frameworks where it's like, I have memory and it's infinite, and processing power is infinite. It's like, well, that's not really true. There's a physical device on which this thing runs, and it has software that makes it efficient or not, and you have to think about how that machine really works to make the whole system efficient. And so we need people who can think at that level. And one of our first hires, Davis Blaylock, he does PhD in systems engineering type stuff for AI. Very low level thinker on that way. He understands the system very, very intimately. Another guy, Abhi Benegala, he came in. Actually,
I know Abhi.
Abhi. Yeah. So he came in actually when I said I'm starting a company on Twitter. He messaged me then, and so people that like want to solve a new interesting problem have the skills of understanding how a system works. That's kind of what we're looking for.
How important is the customer centricity piece? Because you're also defining this. You're on the edge. You're defining this new paradigm. The enterprise has woken up. They're interested in training their own models. And so I'd imagine it's quite a hands-on job for the folks at Mosaic to work with them and to help them. So how much do you need both skill sets, or do you just need all those skill sets to coexist on your team and communicate?
It's more the latter, but what's interesting is I think every SaaS product book actually put everyone in the wrong direction for deep tech. It doesn't work that way in deep tech. Like, it's not about customer interviews from day one. It's about understanding maybe a problem, understanding that very deeply, but you don't put a product when in front of someone until you understand the tech. You may not be able to know what to build until you understand the problem space well. So understanding the problem space is the key, and then actually going and figuring out how to build that with the right team first. It's not about, there's no customer centricity yet. That happens once you have a product. So when you're in the SaaS world, you're thinking about, that's how I present stuff to a user is my UI. Yeah, then you got to think about that from the get-go, because most of your innovation is in the UI. When your innovation is in the tech part of it, first you got to innovate there. You got to build the tech. Then you got to figure out how to package it and sell it. So I think getting that over the hump is your initial task in a deep tech company.
I'm curious how, when you did work closely with customers, how are they thinking about measuring or predicting the ROI of the models that they're training? Like, how much guidance do they need to get there? And I'd layer on top of that, how do they think about the half-life of the models they train? Do they become irrelevant on some period? Is it continuous training? Like, how do you set those expectations when you actually are delivering the product?
Yeah, so that's more of a now question, because that wasn't true when we started the company. So if you remember it then, there were lots of companies that built models and actually continue to build models for forecasting and, mean time between failure analyses. Like, these kinds of things are still bread and butter machine learning problems. And that was actually, I think even today, is probably the vast majority of machine learning are those kinds of problems. And so we were in that world where that was where most people were building things. And there was computer vision front ends, which people were building their own for various purposes. If you're a drone company, you needed to be certain latencies and needed to be able to pick out certain things, preferentially over others. So everyone built their own models at that time. And they would usually have some kind of metrics which they cared about, but they all defined separately. Fast forward to the LLM era, that's when this time to live and all that sort of thing is more relevant, because the investments to build the models are much bigger. The capabilities of general models kept getting better, and then the models started getting smaller, which made them cheaper. So it started to become like, well, build or buy, you make these decisions. And so I think still companies that are doing, I would say, I call them like wacky things, like working in proteomics or something like that, you need to go build your own model, because general foundation models do not work for that. They just do, general knowledge tasks for the most part. When you're very domain specific, maybe that's one reason. Another reason might be if you have very specific latency constraints or you want to decrease costs. Those are reasons to build your own model, or even fine tune an existing model. Then evaluation became a huge problem. It's like last year, everyone kind of thought that an LLM was just intelligence and it'll learn everything. It's like, that's not really true. You have to evaluate it and you have to engineer the solution to work. And so now we've built tools inside of Databricks where we can actually help companies build their evaluation, actually automate the evaluation itself, which is kind of cool. And then let them make choices. I can go with a bigger model or smaller model. I can fine tune a model, or I can do some kind of re-ranking with RAG or whatever. So there's a bunch of techniques we've now established. But 4 years ago, that really wasn't known yet.
Yeah. But I really appreciate that distinction, because I think we'll call it post-ChatGPT mosaic. A lot of the focus on fine-tuning, pre-training. I think it's a popular take that companies want to use their enterprise data, or they want to use whatever data they have access to with intelligent models. It doesn't all fit into training. Sometimes RAG is sufficient. Few shot examples are sufficient. And so it's helpful to hear how you think about it.
I think that's exactly right, though. You got to find the right tool for the job at the end of the day.
Now, when Databricks approached you for an acquisition, given your last acquisition, were there any doubts in your mind? I know that you knew Ali for a while.
Not that long, actually. I mean, honestly, I didn't want to get acquired. That was not really the goal at all. In fact, I had discussions with a few large companies that you definitely know that wanted to acquire us around that time. And I think it happened because we were thinking about a fundraise and all this kind of stuff. But I very politely said no. It was like easy to say no to most companies. With Databricks, it was slightly different. We modeled a little bit how we went to market and how we actually deploy our solutions after Databricks. In fact, I would even say we're like an AI out Databricks, like we're the Databricks of AI in a sense. That was in the pitch. And I think
they're like, we want to be the Databricks for AI.
Yeah. Well, then it became like, okay, I need to build a channel. I need to be able to sell sales apparatus. I need to build all that stuff. And regardless of how much money you raise, it still takes time. And basically, when Ali approached me on this, I kind of had a sense that that's where he was going. I met him first at the Cerebral Valley thing in, I want to say April of 23, something like that. And was it April or March? Maybe March of 23. So we kept in touch. You know, he was giving me some advice on, you know, should we do things with the government and stuff like that, because it's very slow. And, you know, anyway, we were having different discussions on this, and then he wanted to talk. And so I think it was pretty clear to me they were going that direction. And once he said it, he was expecting me to push back. And I said, no, I'm not pushing back. I kind of expected this, but at the same time, it's going to come down to economics.
I mean, it makes sense. To your point on building a channel, my understanding is that as the VP of AI at Databricks, you're really the only like GM who owns an entire unit. So engine sales report to you. I chatted with some folks there, and I think there were 80-ish folks at Databricks working on their ML platform and another 60-ish at Mosaic at the time. What were the biggest cultural differences in bringing these fairly large groups together? How do you bring them together? Well,
one of the theses behind the acquisition was actually that there would be a tight cultural match.
Yeah,
there was. It's a lot of overlap, more so than I would say with most companies. I mean, the team at Databricks, the hiring it has a very high bar. There's like, you know, a great process around hiring, and I think there was a good, you know, kind of mutual respect between the teams when we came in. So it was very different from Intel when I came into there. So I think that actually worked really well. Also, the founders of Databricks are very academic minded, and, you know, I think that worked really well. I think if I were to tease apart and say where the difference is, Databricks has been an execution machine now. They ship stuff fast. They have a lot of great processes around engineering to make it ship fast. I think when you're in these places where the technology is changing often, it's actually very different from a place where the technology is rather stable. Databases, data warehouses, ETLs, those are much more stable things. And you can put down processes that span 6 months or a year. AI is not stable. It's constantly changing at your feet. And what works today may not be that important in 6 months. And so I think that nimbleness is probably the biggest difference. You need to be able to like experiment and go down a few different dead end paths when the world is shifting under you, versus like, I can plan out everything and just execute on it.
What are the most interesting research directions that you all are going down today? Whatever you can share. I'm sure there are some that you can't.
I mean, there's a lot of directions we're taking. A lot of it, I mean, we've published some stuff around compound AI systems. Really, I'm working on another blog on this right now. Really, the idea here is that when we start with any technology, so forget about AI or LLMs. If I start with a bridge, probably the first bridge was someone put a slab of stone across some body of water, right? It's a big monolithic thing that's non-introspectable and really wasn't designed and engineered precisely. That's how everything starts. LLMs are no exception. They're big, inscrutable units that everyone kind of mistook for being, you know, intelligence, really. But it's a piece of software that has properties where they have to be engineered and modified with your data to be useful. So compound AI system is basically saying, well, I want to take this big monolithic thing. I want to break it apart into constituent components, make it so that I can independently develop those, string them together, and build a reliable system end to end. Like, think an engineered bridge versus a slab of stone, right? They both do the same thing, but the engineered bridge is precise and each component is well characterized.
I tweeted when there was the Data AI Summit and Matei was hosting the Compound AI Systems workshop that it was harder to get into than to get a Beyonce ticket. It's not easy. I was on a serious wait list, but I made it. So awesome.
So, but I think this is a generalized concept that we're doing a lot of work around. But I would say the other big concept is, how can I use data that's my data and unique to my organization or my company or my segment, and have an advantage over my competitors? So if I take a general solution that everyone can buy, that's not an advantage.
Yeah.
It's really about how do I modify that thing and make it unique, and then provide a unique experience to my customers, or some kind of really, you know, amazing operational uplift in my organization. There has to be something unique about it. And really that's what we're about. We have the data in the data warehouse. We have notebooks and serverless compute, and now we have these AI capabilities. How do I put those together to actually help our customers do something that gives them an advantage?
Is there a difference in what customers are asking for? You mentioned the world is moving so quickly. So in how they can use their data today versus a year ago, are you seeing a theme around asks that are really surfacing today?
Yeah, I think what we see is it's like fashion trends that go out of style every 6 months or something.
It's funny.
Everything was like, first it was just like LLM. LLM has everything in it. And it's like, well, that's actually not a reliable store of information. So then it was like, oh, that's 100% solved by RAG. It's like, well, guys, RAG doesn't really solve everything. So I think we're coming out of the post RAG thing now. There were like, I don't know how many companies started up, like seed funded companies that said, oh, chat with your PDF, right? It was kind of a joke after a while, or it became a meme. So I think that era has now passed. And now we're in the, I think those are like kind of peak hype, and then we're sort of on that downward slope of, wait, none of this stuff works. How do I ever make anything work? And now we're coming up with these nice engineered solutions that actually solve individual problems, get you to a point of both usefulness and correctness that it supports an application, and to be able to string things together reliably and build something end to end.
How do you then think about building more generalized tools versus a white glove service? Someone has a problem, we're on the cutting edge of research, we can help them. And now I'd imagine in the Databricks role, you're building a platform, and how do you do that? How do you plan for that with these fast cycles?
I mean, we still see patterns emerge. I think it's a combination of recognizing patterns, so talking to customers. I talk to customers, many times a week, and then trying to templatize those patterns, but also then having a view on I think this isn't really going to solve the problem. So there's probably this new technique, and so we're exploring new techniques that can potentially solve those problems that we see today in better ways. And so we can sort of sneak those in as well, and maybe have a solution that's better for a while. So I think it's like you got to react to the templates that you see, the patterns you see, build those templates, and then try to put in some new products or new capabilities that you can experiment with, see what takes hold, and then keep iterating from there. So it's this constant test and iteration loop that we're seeing with users and their use cases.
I'm curious what you're seeing. I'll ask about two unrelated. One is in continuous training and online training. I've not seen much of that in production. I just hear people talk about it. So I'm curious if you are seeing more. And then the other is just in the future of agentic architectures. Everyone talks about agents. There are not a ton in production, but you're hands-on and you're working with these folks. So I'm curious on both.
Yeah, I mean, online learning, it's happening in a slower loop. I guess you can think about everything is actually online learning in a sense. But if I train a neural network, I put it in production, and I gather a bunch of things, and I monitor it, like they used to call it drift or things like that, and then I update it. That's actually online learning, right? The loop is just very long. The loop may be 2 months for it to update. What we're talking about is a much tighter loop. And so now we've tightened that loop a bit, where an LLM is in production, and we actually have monitoring tools that allow you to monitor what went into it, what came out of it, what users thought of it. Was it good or bad? And if they ask more questions around it. So now I can gather all those things. I can actually, in the back end, go and potentially train something else and then update it in production. So we have all these tools to actually do A/B testing in production and stuff like that. So that's tightened the loop a bit. So from maybe months to weeks, maybe days. And then I think the online learning, which you're referring to, is actually a system learning while it's being used. I'll hint a little bit at some of the research we're working on, but that's one of the areas is, can we use the techniques we have now to constantly improve by usage? And that's a general concept, but actually the details are very hard in this area. And, we can use synthetic data techniques. We can use all kinds of different tools that we now have to potentially power this kind of thing. Second question around agents and agentic frameworks. Yeah, I mean, we got to define some terms, I think, because everybody says agent now, and us included.
Yeah, and everyone means something different.
Yeah, we're looking at agents as systems that orchestrate different things, like ask it to do something. It can actually break it into steps, call functions, pull in data, format outputs, and then give you a good, quality output. That's what we're calling an agent. I think the original term came from an entity that has agency, something that can go and just rove around and do tasks. That is very far away from where we are today. What I just defined as an agent, what Databricks defines as an agent, is is something realizable today, and we have a framework to build these things. You have to engineer it to make it reliable. But the true autonomous thing, it's just as hard as an autonomous vehicle. Honestly, like everyone seems to undercall how hard that autonomy is. Getting something to work in all kinds of these edge cases, even if it just lives in a world of data, it's a robot that roams around your data and finds things. It's really freaking hard.
Yeah. I mean, I think it's a definitional thing, right? If you have a human behind the wheel and you're doing some things and a human is supervising it, maybe in real time with driving, it's not a great analogy, but with some agentic use cases, it can work.
Yeah, and I think we're getting there. Maybe this is the path to something that's truly has agency. It really has agency, but maybe not. I personally think there's more breakthroughs that have to happen. These neural networks can't do counterfactual reasoning. They don't do simulation of outcomes and make decisions based on that. They're estimators of LLMs specifically are estimators of conditional probability distributions. Which is incredibly useful. But to train them on the real world would take, the heat death of the universe. I'm actually not joking, because the amount of conditional probabilities out there that you have to condition on every possibility in the world it's too big. It's too big of a set of possibilities. So you need something more constrained than that. AGI is a stupid term because it's not general. It's constrained. It's constrained math. It's constrained probability distributions.
Yeah. I mean, I think this is some of the beauty of compound AI systems too. Like maybe you add complexity by being able to make software calls and multiple LLM calls, but you're also constraining the system, and then you can add more constraints on that system. It sounds like you are working on a bunch of different research exploratory routes. I'm curious how much you think about the non-LLM side of the house. So image gen, video models, classical ML like forecasting. How much do you allocate resources there?
Well, the AI team actually does all of those things. So we have a fair number of resources. I mean, a lot of the resources on research are on the LLM and image generation side, but classical ML, we actually have a pretty large business on that we are continuing to support and build new tools for. We're actually building a unified compute abstraction for all of these things. So any kind of serverless compute will actually be able to do one GPU or N GPUs, with all the scheduling, everything done under the hood serverlessly and completely automatically, which would be a very nice abstraction. That's not something we've actually announced just yet, but we have some early customers on it, things like this. So we're in a place where we're actually trying to unify the compute abstraction. Now, between images and text, the vast majority of our customers use text. We do have an image gen model we built with Shutterstock. We call it Image AI. We announced that at the Data and AI Summit, and it's built solely on their data, and actually it's clean provenance of all their data, which is kind of cool. Anyone can take that. Whenever an image is generated, they're remunerated and we're remunerated. So it's actually like fully clean end to end legally.
Do you spend any time thinking about the future of inference? This is a hot topic now with test time compute, and you've been very focused on the training and everything that goes into that.
Yeah. Well, training and inference are not really different in my mind. I mean, they're kind of different phases of the same thing. I mean, if you look at test time compute, basically what you're doing is you're doing the learning by multiple generations of something and something judging an output. That judgment may be updated. So if you want to look at call training something that updates the way the output happens, then that's still training. You just happen to be using forward passes only. Okay, that's fine. It's still a learning system. It doesn't actually matter if it's updating weights and backpropagation. I don't actually care. Like, I think there are multiple forms of learning, and so that's one version of it. So I think this kind of multiple generations per step and selection is definitely a path forward for the next year. I do see this as being a fashion trend, though. There will be probably something that makes it either you don't need to do that as much, or you don't need to do it at all.
Why do you think it's a fashion trend?
Because it's expensive and slow. That doesn't. It could be valuable, and I don't think it's not the only way to solve these problems, I guess. So again, it's almost a way to do counterfactuals.
Yeah. I mean, I think expensive and slow for some use cases could make sense, and then the question is if there are other methods that are sufficient for those use cases.
Exactly, right? Once you figure out how to use it, then you can go and engineer something potentially better.
You've predicted the future twice. What is the next thing in AI that you are really excited about? And I know that there are multiple. We talked about compound AI systems. What gets you really excited out of bed besides race car driving, which I know you're really good at?
Well, in just pure AI systems, I'll make this a little bit of a longer answer if you don't mind. So in AI systems, I think building systems that can really do true decision making, counterfactual reasoning, and breaking a problem down with sub-goaling in mind. We don't really do that. So essentially giving a machine intention. So when I have an intention, then I can decide whether an action or a decision moves me along the path towards that intent. And we don't have that today. And when we solve that, I think we solve something really big. I don't think that's a simple problem. I think it's going to take a while. To actually get there and build systems that are efficient, I think building the right computing substrate, which we still don't quite have, is still quite inefficient in a lot of ways. So I think these are two big areas I think are going to be hugely important in the next 5 years. I think the counterfactual thing is probably going to be a 5-year problem.
I love that because I think there are multiple, there's the computing substrate, but there's also kind of in the more practical applied side, how do you actually get the right intent at the get-go? So if we're thinking about prompting like we have today, I don't know, can you build a UI or even before the system is doing any computation? So I think there's a lot of innovation on multiple fronts to get there.
Yeah, I mean, one thing that actually came out of SaaS product books that I've read is actually something, I don't remember where I read this, but it's that when a user does something with your product in a UI, they're expressing their intent. They're not doing the thing, they're expressing their intent. It's your job to take that intent and then make it happen, right, through technology. And I think it's no different with an LLM. When someone prompts something or asks you to do something for an agent, they're expressing the intent. So now you have the intent. How do I break that down? How do I sub-goal it? How do I actually, meander my way through the set of myriad possibilities to get to the end result?
Naveen, I love it. And I'll just ask you, in a sentence, AI is getting close to intent. It sounds like you've been really aligned with your own intent since middle school, since you knew you wanted to build AI, since you were voted most likely to succeed and didn't even know about it. How has building Mosaic changed you as a leader and the person you are today?
I don't think it's changed me. I think I learn every time. I learn something new. I learn more about people, how to lead and how to encourage and excite people. I think that's super important. I think how to also set expectations the right way in both directions, up and down. So I think I just keep learning, but I don't know. I feel like I still care about the technology, and really that's been my motivation from the beginning. Success or failure or whatever. It's like, can we actually build something that works and actually changes the way people interact with technology?
I love it. Well, I'm excited to see what else comes out of Databricks Mosaic. Thanks for taking the time. It was really interesting.
Absolutely. All right, great to be on here.